Hello. I'd like to start with a question. What do you see here?
Clouds, excellent, brilliant. Anything else? What else do we see there? A water can. And what's the woman doing?
She's not actually getting water. She's doing something else next to her.
What's she doing? It's a well. She's pulling the water out herself. And she's not using this pump. Now, I see two things here. I see an engineer, I see a community, and I see something missing. Something's gone wrong. This is a graph of the past 3 years, failed water projects that have been running for 3 years or less. And take countries like Sierra Leone or the Côte d'Ivoire, 65% or more of those projects have failed in the last 3 years. Now, why is that? There's clearly a problem somewhere. To take another more extensive survey, in Tanzania, they did a survey of projects older than 20 years. Of them, 10% are successful. 10% are still running in Tanzania that are older than 20 years old. Providing water, let's just take an example. How will we go about this? What do you think we'll do? We think you need a technology. You need something to give people. You need something for them to access this water. You need a community to put it in, and you need the community to work with that technology. And you need the education. Now, research has shown that these three are linked by 6 core stages. The maintenance and operation, so how the thing works, and educating a community. Appropriateness of the technology, health and safety, the rights-based training, software approach, washing hands, water sanitation and things. But we think there's a missing link. We think there's something that is not quite right. That's why in the previous slides you saw that there was a problem, something. And we think that's intermediate education. Intermediate education. Well, first let's talk about what an intermediate technology is. Anyone been on a placement and put in an intermediate technology, or what do they think an intermediate technology is? Any ideas? Anybody? Say, if you know.
It's a technology that can be locally manufactured and is appropriate to the scale and geographical locality of the community.
Yep. So the direct definition is it's designed with special consideration to the environmental, ethical, cultural, social and economic aspects of the community it's intended for. So someone's actually gone and thought about what the community needs and appropriately designed a technology that's not too complicated, not too simple, but appropriate for that specific community. So then simply, intermediate education is all the scientific and technical teachings behind an intermediate technology. So what is Project DIEM? Project DIEM, we aim to facilitate development by encouraging scientific and technical growth in some of the world's poorest countries. Our objective is to develop and produce a comprehensive science and technology manual that will enhance the standards of science education, focusing on experimental learning. And experimental learning, what do I mean by that? I mean using physical experience, using your hands, actually interacting with something instead of just learning didactically off a board why something works, seeing for your own eyes why something works. I'll add at this point that this is not about the operation and maintenance. This is not about HIVAs. This is not about all the other things that might have been included in the previous slides that you saw. It's because they're being done already, and they're being done quite well, and with a lot of research and a lot of funding. But this is where we see the gap is. So this is specifically about the intermediate education. Process structure. So how are we going to go about actually creating this material for people? Well, it starts with you. It starts with people all around the world coming up with ideas, and they come up with an idea to do with a technology, and they put it on a central area. It could be a scientist, a teacher, it could be an NGO worker, it could be anybody, a student, anybody. And where do we put those ideas? We put those onto a central database, a wiki, just like Apropedia, Wikipedia, centrally have something which everyone can access around the world. Then, of course, you test it. You take that material, you put it in the UK schools in a developed country, and you test it. And the feedback from that test should go back into the wiki, back into the material to be updated so that it's more appropriate. And of course, that's not the same as doing it in a developing world country, so what's the next stage? It needs to be trialed. So the material needs to be then further trialed in a country that's in a developing country. And once the results of that have happened, again, fed back into the wiki. And then as best it can be developed, material is ready for people to be, teachers to be given this material, and it can be taught. So, this material thing, what am I talking? What is material? Start with just an engineering concept, a biosand filter. Some of you may know what it was, but basically it takes dirty water, put it in the top, it goes through the filter, up the siphon, out, and it comes out 99.9% clean. And there's a lot of more complicated process behind it, but that's the simplicity behind it. So what do? We take this piece of technology, and we break it down into its scientific principles. What is going on in this thing? We have filtration, we've got siphoning, we've got a diffuser plate which just dribbles the water on. So little things that are going on to help people understand what it is. So there's a few examples of what's going on in there. And from that, we create experiments. And in the experiment, we create hands-on workshops with bottles, with anything you think is readily available. And that's a key thing, is when you create this material, you've got to think, are people going to have this resource? There's not, a finite list that says this is all the resource people have in developing countries. But just when it's being developed, you've got to think, I can't use complicated and expensive equipment. I've got to use really basic things to translate complicated ideas. So once that's developed, what do? We put it onto our wiki. This is currently embedded in the Edinburgh Engineers Without Borders UK website. But after this weekend, hopefully it's going to have a page in the EWB UK website. So anybody can access it and modify it, change it, and it can just become a project for everybody. And that's a really important thing. It's not a project for Engineers Without Borders, Edinburgh, EWB. It's a project for anybody to get involved in anywhere in the world. We are merely creating the base, because it's easy for someone to come to you with an idea and you go, yeah, that's a really good idea, but there's no substance behind it. But if there's substance, and it's not the best, like we're not perfect, but someone can actually work on what we do, as opposed to just working on an idea. Okay, so what comes next? You test the material. So this is a sand filtration we tested in Edinburgh. We gave them a problem, and the problem was to, here's all your materials, make a biosand filter. We gave them sand and stones and things, and they thought about it, they went through the processes, they got it wrong, they got it right, and gradually, after getting it wrong and getting it right sometimes, they learnt. And the results kind of mapped that. This is the water they started with, a couple of experiments in the middle, and by the end, some of the groups actually came up with some really good results. And of course, this is merely the physical cleaning of water. This is not the biological cleaning, but it gives in a child's mind the process that you can do something to water and it can become, quotes, cleaner. So that's the mental steps you're trying to make. And then what we do, we test it in the overseas placement. So this is actually a project in Cambodia which we link with, that's also through Edinburgh branch. So using an existing project, the communication's really easy between the two projects, and you can use that to feed each other ideas. So that's what happens there. And of course, the teaching part, the last stage. What's the form, what's the structure of this material actually going to look like? How do we overcome the language barrier? How do we overcome the fact that people don't speak English and are going to have a real problem understanding more complicated things? Well, that's not for us to decide, but we can definitely think about it. So this is an idea we came up with, just using basic pictures and basic English. I mean, think about IKEA. You don't build something from IKEA with words and lists. You build it from a diagram. And that is so much easier than words and lists. So we'll apply sort of the same mentality to producing this material. So how to get involved? Of course, this project, like I was saying, would be great if this expands to anybody else who's interested, and it applies to lots of projects and placements. In fact, any engineering that's done in any placement could use backup material to help the community link with that project. So you could design and build, come up with your own workshops, design and build, and then someone else can come and test that. You can do the testing either here in the UK, or you can go test it out in the field on the trial. And the last one is project support. Project support is how you run it in your branch, how you interact with the sort of central area of the project, and and the general running of the project, and making sure that everyone is collaborating to the same aims and objectives. That's our website. That's our email. And thank you very much for listening to me.